Hey guys, welcome back. So today you are going to be doing this really quick assignment with just 3 practice problems. I'm going to do the first one for you as an example. So you only have to do B and C. If you don't want to write out the first problem, it's totally fine. As long as you watch this and use it as an example, you'll be okay. So I'm going to work mine just on a Google Doc, but you guys will do it on a separate sheet of paper and then just take either do it in a text entry box or you can do it as a file upload. I'm just seeing where I did give you the option to do it in a text entry. So whichever way is better for you guys. I think it would go a little bit quicker if you did it by hand on a separate sheet of paper, but again, it is your prerogative. So we're doing empirical formulas today. And I do want to point out that the first one is in grams, and then B and C are both in percentage. Remember, all you have to do is convert the percentage to grams, so 72.36% will be the same as 72.36 grams. So I just wanted to point that out. All right, so the first one we have aluminum and oxygen, so that's going to be aluminum oxide, and we have to do the empirical formula to figure out how many of each atom that we have. So I'm just going to pop over to my Google Doc and type everything down. So I have 2.646 grams. And 2.355 grams of oxygen. Perfect. All right, so the step one is to convert to grams, which this one's already in grams. If it was percentages, we would just convert it to grams, but it's already there, so we don't have to. Step two is that we are going to have to convert from grams to moles. So I'm going to do aluminum first, and then I'll do oxygen. So anytime we do a gram to mole conversion, we have to start with what we know. So we have 2.646 grams of aluminum. And we're going to multiply that by our mole conversion. So let me go ahead and put in a fraction so I can keep everything straight. Okay, so I know I want to eliminate my grams. So my grams are going to be on the bottom and my moles are going to be on the top. And anytime we're doing we're getting a conversion factor, 1 mole will be equal to something. So if we were doing a particle conversion, 1 mole is 6.022 times 10 to the 23rd particles, but here we're doing grams, so we have to find the molar mass of aluminum. And remember, we do that by using our periodic table and our average atomic mass. So 1 mole of aluminum is also equal to, let me find aluminum here, is also equal to 26.982 grams. So remember, the average atomic mass is also the molar mass. So 1 mole of aluminum is 26.982 grams. Remember, if you have multiple atoms in a compound, you would have to multiply it by however many you have. But here, since we're looking for the formula, we're just doing simple conversions, so we're only going to have to use the average atomic mass because that's the same as 1 mole. So 26.982 grams for the aluminum. Okay, so 1 mole of aluminum is equal to 26.982. Again, that comes from the periodic table. So now let's do the math on this. So I'm going to go to my calculator. You could also use Desmos, the calculator on your phone, whatever you have available to you. So 2.656 divided by 26.982 equals 0.098. So I'm going to do 0.098 moles. Okay? So here our grams eliminated, and we were left with our moles. Perfect. Remember, this is just fractional math, so you would just multiply through the top, multiply through the bottom, and then divide. Because there's a 1 on top and a 1 on bottom, it was just a basic division. Okay? Now let's do oxygen. 2.355 grams of oxygen times, again, we're converting to moles, so 1 mole of oxygen will be equal to 15.999 grams, because again, that's the average atomic mass. Okay, so now we're going to do our math here, because our grams are going to eliminate and leave us with our moles, which is what we want. .1478, so I'm going to round that to 0.148. Okay, so now we have our moles. We're going to have to take our smaller number and divide each by the smallest number of moles, which is going to be that 0.098. Okay, so for aluminum, it'll be 0 divided by 0.098, which of course will just be 1. And for oxygen, it'll be 0.148 divided by 0.098. So 0.148 divided by 0.098 will give us 1.5. Okay, here we have a problem, because 1.5 is not a number we can use as a subscript, right? Normally in the examples in our lecture video today, everything worked out perfectly and we didn't have this issue where we had a 1 and a 1.5 or anything that wasn't a whole number. But we can't have decimals, remember, as our subscript. So what we're going to have to do here is we are going to have to multiply by a factor until we can get this 1.5 to a whole number, okay? And right off the bat, I can tell if I multiply it by 2, right? If I multiply it by 2, then we should be able to get our whole number, because 1.5 times 2 will give us 3, which is a whole number. So I'm going to go ahead and multiply by 2. And so those are whole numbers, so we can use those. So the empirical formula is Al2O3. Okay, that is the empirical formula for, this would be aluminum oxide. Okay, now this is actually a ionic compound, so you could check yourself with your swap, drop, and chop to make sure you're right. So let's go and do that really quick. So aluminum is a 3+ charge. Oxygen is a 2- charge, so we're throwing it back to when we did ionic and covalent compounds. So if you have, just do it on the screen really quick. If you have aluminum with 3+, and then your oxygen with your 2-, we can swap, drop, and chop. So the 3 comes down to become the subscript of the oxygen. The 2 comes down to be the subscript of aluminum. So it would be Al2 O3. And I apologize for my terrible drawing. So Al2O3. That's based on what we know about ionic compounds. So we are correct. So you can double check yourself that way if it's an ionic compound, just to know that you're right, but we are correct. So the answer to that would be Al2O3. So you don't have to do A when you're writing it down. If you wrote it down while you're doing this video, perfect, but I want to see you guys do B and C. Again, you can either do it in the text box, and it should just look similar to this. So if you're doing it in the text box, this is how you would show your work. And of course, if you're doing it by hand, you just write it down. Okay? If you have any questions, let me know. And if not, I will catch you guys in the next lesson.